I think you guys can fly through these notes on your own, but here we go. The area of a rectangle is, did you guys put your name up there? Put your name up there. Don't forget your period and the date. Today's the 21st. The area of a rectangle is A. Let's see. Let's write this. Let's go A equals base. Whoa, that's too thick of a pen right there. Okay, base times. Times isn't a good. You should write multiply, but I'm writing times because it's smaller. Times height, HEI, right? It's HEI, right? Or you can say B times H, where B is the base. I'm just being really explicit here, I guess. And H is the height. Okay, now this is good stuff. This is your base. I mean, really, you can make the side your base, but we're used to the base being on the bottom. This is the most important thing. Remember that the base and the height must be, they have to be perpendicular. Now that's pretty simple for a rectangle, because in a rectangle the base and the height are always going to be perpendicular, because if they weren't, it wouldn't be a rectangle. So when we go down to problems like this, I'm not giving you a really basic one, but here you go. If the perimeter of a rectangle is 36 inches and one of the sides is 5 inches, what is the area of the rectangle? So let's draw ourselves a picture. Here's a rectangle right here. Draw a little right angle right there. Other important things to know about rectangles, which you guys should know, is that side is congruent to that side is congruent to that side, and that side is congruent to that side. Okay, now it says one of the sides equals 5. Now, what is this word right here? What does that mean? Perimeter. Sum of all the sides. She used her academic language. She said the word sum. It's a sum of all the sides. Are there any numbers, other numbers I could put on my picture?
Yeah, you can put 5 on the other side.
I put another 5 right here. Now, I don't know this number and I don't know this number. Now, a perimeter says, you said 5 plus 5, the sum of all the sides, that one and that one, equals what? 36, right? That's what the problem says. So if you're trying to find this out, we normally don't write question marks in algebra. What do we write instead of question marks?
Variables.
Yeah, variables. Let's put an X right there. So instead of writing that question mark right there, we'll throw an X right there and an X right there. Okay, we have 2 X's. So we simplify, we have 10, and we have 2 X's. We add all those up, we're supposed to get 36. First thing I would do, I mean, you could divide by 2 first, but I like to subtract first. So I subtract with 10, so I have 2x equals 16. Then I divide both sides by 2. You got me. I was just seeing if you're paying attention. 2x equals 26. And I divide by 2, I get x equals 1 and 3. That's 13. Wait. Is that my answer? No, foos. Wait, what does it say? What is the area of the rectangle? Oh my goodness. You guys almost let me do it wrong. You all stink. You always need to go back and double check. Make sure you know what the question is asking. You know how many students will just box this as their answer? And they'll be like, yay, I'm done. No, you're not done. Okay, because that is not the answer. You put 13 right here, and now you can figure out the area. Oh, the area is base times height. What is my base?
5.
Sure, we can make it 5. And my height is?
13.
Yeah, because it doesn't really matter. When you multiply, the order doesn't matter. So we get 65?
Yeah.
65 what?
Inches.
Inches squared. Don't forget that. Units squared. So 65 inches squared is your answer for that one. It asks for the area. Let's go to the next one. A rectangle has a diagonal of 13 and a base of 12. So let's draw ourselves a picture. Here's our rectangle. Here's my diagonal. Oh, bad diagonal. Better diagonal. That's 13. And we know this, we know this, we know this, we know this, and we know this. Okay. Do we know anything else? Am I missing something on my picture? Yes, I'm missing the 12. The 12 is the base. I'm going to put it right there. Alright, how am I going to find the area of this dude? I need to have... what? Yeah, I see a triangle. It's right here. Oh, Pythagorean theorem. That's what you're trying to say. He was trying to say Pythagorean theorem, but he was like, triangle, triangle. Didn't know what he was doing there. Plus, and I'll throw x there like what we did before. So, there you go. A squared plus b squared equals c squared. That's our Pythagorean theorem. We get 169 right here. Oops, not 166. 169 equals 144 plus x squared. Some of you guys don't even need to look at the screen to do this. You know it already. When I subtract 144 from both sides, I get 25 equals x squared, which means x equals 5. So not x anymore. I have a 5 right there. Now can I find the area? Yes, the area of this rectangle equals the base times the height, which is 12 times 5, and that equals 60. And don't forget, inches squared. Sorry, not inches, centimeters. Good looking out. Alright, next thing on our list, parallelograms. Parallelograms. Alright, so what we're going to do right here is have a little activity plan. So if you take a rectangle and you cut it up to make a parallelogram, like I just did right here, first note that my squares right here, like the length right here, I can barely see the blue. Let's do red. I can't see the red either. Can you guys see the green? Yeah, green's a little... Okay, anyways, the length right there is going to be a 13. Okay, you guys might have a different one. That's the length right here of my rectangle. The height of it right here is going to be 6. What is the area of this rectangle? It is, what did we say before? 78? It is 78 squares. It's actually units squared. Because there's 78 squares in all these. And I'm talking about these squares right here. Let's see, let's get a different color right here. Purple? Yeah, purple pops on there. Okay, there's 78 of these squares. If we actually counted all these, we would count 78. And all you have to do is you have to go 6 times 13. Okay, because that's the length, or the base and the height of this rectangle. Now, by cutting this right triangle off right here, we could take that right triangle and we could put it over here. And if we do that, we have a parallelogram. Our parallelogram looks like this. From here down, right there, and right there. This parallelogram still has the same number of squares, of units. It still has the same area. So when it comes to finding the area of a parallelogram, it's the same as a rectangle. You're going to take the base, in this case is 13 still, and then you multiply it by the height. The height, though, is in a different spot. It's kind of inside of the shape, which we have to get used to seeing. But note that the height still is perpendicular to the base, just like, exactly like the rectangle. So when we go to this question right here, and it says, what do you think is meant by, let's see, what does it say? It says, what do you think is meant by when we refer to the height of a parallelogram, and how is that different from a rectangle, and how is it the same? You guys can look at that and you know, be able to describe it to me. Here's a rectangle. This is your base. This is your height, and then this right here is a parallelogram. But for a parallelogram, this is your base and this is your height. What is the difference between this height and this height? What is the difference between these two heights? Come on, I heard some good answers out there. Yeah?
The parallelogram's height is a height has to be completely vertical in order for it to actually be the height. Otherwise, it's what's called the slant height.
That's true. This would be the slant height, and this is the actual height. What's the difference between these two heights? When you look at these shapes, are the heights actually different? No, they're not actually different. But when you look at the shapes, where is the height in the parallelogram as opposed to the height of the rectangle?
It's in the same place. It's
inside of it. This one right here is inside the shape, and this one's on the outside. Now sometimes we can get no. Well, I mean, this is a parallelogram right here too, when you think about it. But anyways, let's move on to some examples. What is the area of this parallelogram? So something to note here is, well, you guys know the height. What's the height for this one? 8. 8 is our height. That's our height. What's the base though? Is the base going to be 10, or is the base going to be 23? Yeah, it's actually 23. So we would have to go 8 times 23. The area of this parallelogram is 8 times 23. When I go 8 times 23, that's 160 plus the 18. No, plus the 24. 184? Is that what you guys got? I'm doing it in my head. You guys get the same thing? Okay, that's meters squared. Okay, don't forget the meters squared. That's important. Let's look at some other examples. Now, it's very important here to note which one's the base and which one's the height. Okay? Which one is the base for this one? Yeah, for letter B, your base is your 8. And what's the height?
9.
They have to be perpendicular here. Okay, so that means the area for this one is going to be 8 times 7, which is 70. No, what am I doing? 8 times 9, which is 72. See, I was thinking the 7 and the 72. Centimeters squared. Okay, what's the base for the next one? Is it going to be the 9 or is it going to be the 12? Yeah, it's the 12. So the area for this one is 12 times what? 7. You see how like there's decoy numbers there? That's a decoy number. That's a decoy number. We don't. Oh wait, that's not a decoy number. This is the decoy number. We don't need those to find the areas. And this is 84 centimeters squared. Did I do everything right? Yeah, I did everything right. So here's kind of the same thing we did for the rectangle. The area of a parallelogram is base times height. I'm just going to do a dot this time. Times height, which can be written as lowercase b, lowercase a, where lowercase b is your base, and lowercase h is your height. And this is actually almost all the same as the rectangle. This is your height. This is your base. And it's very important to remember that the base and the height are perpendicular. Now here's a parallelogram right here that's missing the height. Where's that height? So how would we find this height? Yeah, we have a right triangle right here, so what would we use? Pythagorean theorem. So you would say 100 squared equals 6 squared plus, we're going to say h squared because this is h. So we have 36 right. What, did I do something wrong?
10 squared, not 100 squared.
Oh, see, I had that problem. Remember I was telling you guys? Okay, so that's 100, that's 36, that's h squared. If I subtract 36 from both sides, I get 64, right? 64? Come on, check me. I always do stuff incorrectly. Okay, and then I take the square root of both sides, and so I get 8. My height equals 8. Now I'd be able to find the area. Just for fun, what's the base?
20.
No, it's not 20. Oh, I got you. Okay, it's 26. You have to add the 20 and the 6. So it's 26 times 8, and that would give you the area of this parallelogram.